Hi everyone. Today we're just going to look at the periodic table and atoms and elements to help you with some of your work and your studies. So this is a periodic table. It's something that you guys will become very familiar with over the next couple of weeks. We're going to use it a lot. This is a very simple one. The one you'll be provided in class is a little bit more detail on it. But basically what we're looking at here is a list of all of the elements that have been found on planet Earth. They're grouped in certain ways that we will discover later on. But basically, what we're looking at here, the big concern for us right now is the fact that they are arranged according to what we call atomic numbers. So notice this is 1, then we have 2, 3, 4, and so on. Okay, so that's how they're arranged. They're not arranged alphabetically or anything like that. They're based on the atomic number. That's how the periodic table is arranged. So what does that mean? Well, let's take a look. Let's zoom in for a minute on carbon. So this is kind of the box that we would see on a periodic table for carbon. Of course, we have the name up here. Then also we have its symbol here, its chemical symbol, something that you guys will come to learn, love, and memorize before your first test. So there's its symbol. Then we have this number here. This is that atomic number. So atomic number. What the atomic number is the number of protons. So carbon has, oh sorry, this came up kind of weird. Carbon has 6 protons. Below that we have this number here. This is the atomic mass, which is exactly what it sounds like. It is how much carbon or an atom of carbon weighs. The atomic mass is made up of number of, so this is going to be made of the number of protons plus the number of neutrons. Okay, so atomic number is just the number of protons. The atomic mass is the number of protons plus neutrons. We'll learn later that it's not actually the number of protons and neutrons, but for right now, that's what we're going to consider for the atomic mass. So here's an atom. So this isn't necessarily the atom of carbon. In fact, it's not. But this is kind of what we think atoms look like. So in the center here, say in blue, we might have neutrons. Okay, so neutrons here in blue, these have no charge. They are neutral, hence their name. But they do have a mass of 1 AMU, which is atomic mass unit. So they do provide the mass. Then also we have these red guys here. These are our protons. They do have a charge. Their charge is a +1 charge. And they also have a mass of 1 AMU. So that's why the atomic mass is protons plus neutrons, because those two things contribute to the mass. These two things together are known collectively as, so this thing here is known as the nucleus. So all of the mass of an atom comes from the nucleus. So what's cruising around out here? These are electrons. This one happens to have 3. I don't think that's quite true, but this one happens to have 3 electrons. And electrons do have a charge, so they have a -1 charge. But they have negligible or no, essentially, mass. So they don't actually contribute to the mass. Now you'll notice that in this diagram you have 3 red protons and 3 green electrons. That's not by fluke. Neutral elements have equal numbers of protons and electrons. So let's take a look at that. So we're going back to our periodic table. So if we look at something like, I don't know, let's look at nitrogen for now, okay? So if we look at nitrogen, it says 7N, and then underneath it says 14.007. So if I asked you, say, how many protons there are, you would say 7 protons. You just say P plus. That's a plus. If I asked you how many neutrons there are, you would do 14 minus the 7. So 14 minus 7 equals 7 neutrons. That's from using the mass minus the protons. And if I ask you how many electrons there are, there will be 7 electrons. Because in a neutral atom, so there's no charge here, the protons are equal to the electrons because 7 pluses and 7 minuses equals 0, or neutral. So let's take another look. Here we have chlorine. Okay, so chlorine usually has 17 protons, which means it also has 17 electrons. This is what it looks like actually, and we'll learn later on a bit more about what this is all about. So in the nucleus here, we would have our protons and we'd have our neutrons. Then out around here, these are all our electrons, 17 of them. Okay, so all out here would be our electrons all the way out there. So you'll see here that this is chlorine, it's neutral, so the protons are equal to the number of electrons. However, chlorine very often makes Cl minus 1. Okay, we don't include the 1, it's just Cl minus, but that's actually technically Cl minus 1. Okay, but we just don't usually write the minus 1. So when Cl, or chlorine, makes an ion, it's usually going to make Cl minus 1. So what that means is this has gained 1 electron. It's gained 1 electron because it's now become -1. Okay, so now the number of protons and protons and electrons are not equal. There's 1 extra electron. So if I asked you how many electrons there are here, you would say there are 18. Because it used to have 17, but it gained 1 electron. So they now have 18 electrons. The next thing to talk about is isotopes. Isotopes. What's an isotope? Well, here we have carbon. Everything looks the same. Still has this mass of 12.011. Previously, I told you that the atomic mass is usually the number of protons plus the number of neutrons. Okay. For right now, that's fine. It's not actually what it is. What it actually is the average of all isotope masses multiplied by their abundance. I'm gonna run out of room. Maybe I can scroll over. Nope, no scrolling. Abundance. I'll squish it in. Okay. So it's an average of all isotope masses times their abundance. So what the heck does that mean? So what that means is out there on the planet, there are different weights of carbon. They don't all weigh 12.011. There is, in fact, C14. And if you read about dinosaurs or radiocarbon data, they'll talk to you about C14. There's also C11. There's C13. The most abundant is going to be this one, C12. But it's not the only one out there. So how do things get heavier and lighter? What an isotope is it's an element or an atom of an element with a different number of neutrons. So we can add and remove neutrons. So for instance, in the case of carbon-14 over here, let me just get rid of these extra ones here. In the example with carbon-14, usually carbon would have 6 protons and 6 neutrons if we look at this one here. However, in the case of carbon-14, carbon always has 6 protons. That's what makes it carbon. If you change the number of protons, an element becomes a different element. It's not carbon anymore. So it always has 6 protons, but in this case, it's going to have a different number of neutrons. So 6 protons and 8 neutrons. So it's heavier. It's literally a heavier version of carbon. And that's what an isotope is. It is an atom with a different number of neutrons. So let's just quickly summarize what we can change and what we can't. If we change the number of electrons, so change electrons, you get an ion. Okay? What is that? It is a charged atom. If you gain electrons, you become more negative because you've gained negativity. If you lose electrons, you become more positive. And I always think about it like if you lose negative friends, you become more positive. So if you lose electrons, you become more positive. So what you become is an ion. Just some extra terminology here. If you become negative, they call you an anion. And if you become positive, you're called a cation. I remember this because cats have paws. So that reminds me that cations are positive. So we change the number of electrons, we make a charged atom, also known as an ion. If you gain electrons, you become negative or an anion. If you lose electrons, you become positive or a cation because cats have paws. Now, if you change the number of neutrons, also known as N with a 0 because it has no charge, then what you do is you make an isotope. So you're the same element, but you're an isotope. You're a heavier version of that element. For example, normally we have C12, but there's also C14, C11, and so on. Now, the big one, if you change protons, change the number, I should say, of protons, number of all of these things, really. Change the number of protons, you are a different element. The element that you are depends completely on your number of protons, on your atomic number. So the atomic number is specific to an element, whereas you can change the electrons and you can change the number of neutrons by adding or losing any of those. You cannot change the number of protons and still be the same element.